In this video, we define the determinant, a tool of linear algebra. The definition of the determinant is highly unintuitive, and it's hard to explain what exactly it does. But unfortunately, we will need it for something a little down the line. The determinant is a number associated with a square matrix. It is defined inductively and is kind of a hassle. The determinant of a 1 by 1 matrix is the entry of the matrix. The determinant of a 2 by 2 matrix. Notice that this is the same notation we used when we defined the Wronskian, is obtained by multiplying the diagonal elements, multiplying the anti-diagonal elements, and subtracting them. We define the determinant of a 3 by 3 matrix inductively. We'll start by creating a sign chart of the same size as the matrix. We start with positive up here, and then alternate signs. We pick a row or column. It doesn't matter which one, which is really surprising considering how contorted this whole process is. I'll select the second row. We're going to multiply this first element by something. Multiply this second element by something, and multiply this third element by something. And we'll consult our sign chart. We have a negative sign corresponding to this. So we put a negative sign here. We have a positive sign corresponding to this. So we put addition here. A negative sign corresponding to this. So we put subtraction. subtraction there. What are these somethings? They're determinants of smaller matrices. In particular, to find this term corresponding to A sub 2, 1, we're going to cover up the row containing A sub 2, 1 and the column containing A sub 2, 1, and we're going to turn these 4 remaining terms into a matrix. We take the determinant of that matrix which we can do. We know how to take the determinant of 2 by 2 matrices. We repeat this process. You can see how this could be kind of tedious. This is a lot of operations to perform, and it gets worse quickly as the matrices get bigger. So this process generalizes if the matrix is larger, although it always needs to be square. If we have a 4 by 4 matrix, we can define its determinant in terms of the determinants of 4 3 by 3 matrices. We then find the determinant of each of those 4 3 by 3 matrices in terms of the determinants of 2 by 2 matrices, which we can then find by multiplying and subtracting diagonal and anti-diagonal elements. However, if we could perform 5 operations a second, addition, subtraction, multiplication, or division, it would take about 3 years to compute a determinant of a 12 by 12 matrix in this way. For large matrices, even computers will not be able to perform this algorithm in a reasonable time. In linear algebra, we will briefly consider alternative algorithms, although speaking bluntly, the general consensus is that you shouldn't be computing determinants. They are a theoretical instrument. In this class, we will not require students to compute determinants of matrices greater than 3 by 3 in size, unless perhaps the matrix has some feature, like a lot of zeros, that will speed up the calculations.